Well, welcome to this online revision session for AQA M2, in which we'll be looking at the January 2011 question 5 on circular motion, which is in a constant rate of rotation, and this particular question involves friction as well. So in the first part we have a coin which is on a rough turntable, and it's a distance of 0.8 from the centre of the turntable as the turntable rotates at a constant angular speed. We're told the friction between the coin and the turntable is 0.3, so that's our coefficient of friction, mu. We have to find the maximum angular speed in radians per second, that's omega, at which the turntable can rotate if the coin is not going to slide off. So we know as it rotates round that the mass of the coin, and hence its weight, will be acting down, and then we have a normal reaction acting in the opposite direction. And then there must be a frictional force acting towards the centre of motion, of the circular motion, that is maintaining the circular motion. Now if the turntable is rotating at its maximum speed, so the coin does not slide off the turntable, then the frictional value must be at its maximum value, at its limiting value. So we know that F, the friction, must be equal to mu r under these circumstances. That is the key thing. And we also know that r must be equal to mg, the weight, since the coin is resting on the turntable. So combining those two things together will give us the fact that F, the frictional force, must be equal to mu mg. Now it's that frictional force that is maintaining the circular motion. So we therefore know that the frictional force must also be equal to m r omega squared, the force towards the centre of the circle that is maintaining the coin in circular motion on the turntable. So combining those two things together, we have the fact that mu mg must equal m r omega squared. So in fact m must cancel out of that, so we're just left with the fact that mu g is equal to r omega squared. Now in this part of the question we're being asked to find the value of omega under this situation. So if we rearrange this, we will get the fact that omega squared is equal to mu g over r, and we know the value of mu because that's 0.3. We know the value of g, that's 9.8, and we know the value of r, so that's the radius of the circle, which is 0.8. And so we can then throw that into our calculator and square root it to find the value of omega, and that will give us 1.92, and of course that's in radians per second. and that answer is accurate to 3 significant figures. Okay, right, fairly straightforward that first part. Well, for our 4 marks, recognising that f is equal to mu r in this particular case, we will give you 1 mark. Then recognising that f must equal mr omega squared, that will give you a mark there. Then rearranging and substituting in the values, 1 to get to this point will give you 1 mark, and then finally to get the answer that you require will give you 1 mark. Okay, so 4 marks fairly straightforwardly found in this particular case. Now, part B, the coin's replaced and an old coin is placed a distance of 0.5 metres from the centre. Turntable is made to rotate, but this time at an angular speed of 45 revolutions per minute. So part 1 asks you to convert that 45 revolutions per minute to an angular speed in radians per second. So we have 45 revs per minute. Okay, well, 1 revolution is 2 pi, so 45 revolutions will be 90 pi. So that's 90 pi radians in a minute. So if we want that in a second, we will have to then divide that by 60. And so that simplifies to 3 pi over 2. And that will be radians per second. Part 2 then states that the old coin remains in the same position on the turntable, that's 0.15 metres from the centre. This time we've got to find the least value of the coefficient of friction to prevent the coin sliding off the table. So it's basically the same problem as before. F will equal mu r because it's on the point of slipping. The same working goes through, so we can use this result from here, the fact that mu g equals r omega squared, with our new set of values. So we can write down the fact that mu g must equal r omega squared. In this case we know r and omega and g, and we're trying to find mu. So mu must equal r omega squared over g, which is going to give us a value of r, which is 0.15, times omega, which is 3 pi over 2 squared, and then that is all divided by g, which we can take as 9.8 meters per second squared. And if we now put that through our calculator, we will end up with an answer to 3 figures of 0.340 to 3 significant figures. Remembering that mu, the coefficient of friction, does not have any units. So once again, for obtaining the correct expression, we'll have a method mark, and 2 answer marks, one for getting each side correct in the expression, and then finally for working out the value that we require, we get 1 mark for that. Oh, and I should have said really, I suppose, the marks for part 1 as well. That's fairly straightforward in that it'll just be a method mark for realising how to convert revs per minute to radians per second, and then an answer mark for obtaining the correct answer. Hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.